This is a video for section 8.1. Today we're going to talk about parabolas. Chapter 8 is all about conic sections, and conic sections are formed when you have two napes or cones, which form the upper nape, which is this cone, and the lower nape, which is the bottom one. What happens is when I take a cross section of this, depending on where I take that cross section, I can end up with a couple of different kinds of conics. The one we are going to talk about is the parabola. And what happens is when I take a cross section, I only go through one nape. I can go through the upper or lower, it just depends. But when I cut this cone in half at an angle, I end up with a parabola shape. So what is a parabola? A parabola is the set of all points in a plane equidistant from a particular line. Now, equidistant means equal distance from a particular line, which is the directrix, and a particular point in the plane. So what they're saying is from the focus, which is this point here, to the graph, then to the directrix, these two lines have the same distance. And that happens for every single point on the graph. So if I went from the focus to this point on the graph, that distance would be the same as going from that point straight down to the directrix. Those are the same, and it doesn't matter where I go on the graph. If I go over here, this distance and this distance are the same. So understanding the focus and where the directrix is an important piece of this puzzle. So we have some vocabulary that we're going to have to make sure we understand. We need to understand focal length. And this is the distance from the focus to the vertex and the vertex to the directrix. So if I go back here and I look, this distance right here is the focal length. And that's the same as this distance here. Because remember, any point from the focus to the graph and the graph to the directrix is the same. So these have the same lengths, and that's the focal length. The next piece we want to talk about is the focal width. This is the length of the chord through the focus perpendicular to the axis. So if I go back again, if I go through the focus out to the graph, perpendicular to the axis. Now notice the axis, I went too far. Okay, the axis runs this way. So these two guys are perpendicular to each other. So the distance from here to here is the focal width. So we have focal width and focal length. Okay. Now you have a formula sheet, and on your formula sheet you should see a box that looks similar to this. The standard equation for a parabola is either an x quantity squared or a y quantity squared, and it matters which one I'm talking about. It matters because it either opens up or down if x is squared. If the y part is squared, then it's going to open to the right or left. So here, my parabola is either going to do this or this. And we've seen these before. Over here, my parabola is either going to do this or this. So we have to be able to understand that if it's x, I'm going up and down. If it's y that's squared, I'm going to go left or right. Now, how do I know which way it's going to open? Well, it's up if p is positive. It's down if p is negative. Same thing here, it's right with a positive p, left with a negative p. So you may want to write those things on your sheet. Now the focus is a point on the coordinate plane, and it's located from the vertex up p or down p. And the focus is always inside of the parabola. So it's almost like the parabola is always eating the focus. The directrix is a line. So that may be something we want to note. The focus is a point. The directrix is a line. Right? The axis is the line of symmetry that cuts the parabola in half. Focal length is p. Focal width is the absolute value of 4p. So we'll see that we have our 4p here in our equation. So the absolute value of that is our focal width. For width is a distance. We don't care if it's positive or negative. We just care what the distance is. So that's why it's the absolute value. Now, what do they look like? So here is our graph. And part of your job today is going to be able to draw these graphs. So in doing so, you need to understand what you're labeling. So first, I have this point, which is my vertex. Or this point, HK, which is my vertex. Then I have this other point inside here. Notice how it's eating that point. That's my focus. The same thing over here. Focus. And then the directrix would be the line out here. It's the same distance p away from the vertex. And you're going to have to label here.
I said, you're away. He said, yeah, he already did. He said, babe, why do you want to run the preacher? He goes, no, if I'm a son of a preacher, does that matter?
And so this is what you're going to have to label on your graph when you're drawing these graphs. We need to know the directrix, the vertex, and the focus. Where are all of these things at? So let's get to some problems. Find the vertex, focus, directrix, and focal width of the parabola. So you're going to want your formula sheet. So we want our formula sheet sitting next to us when we're doing these. And we go through, and I have x squared, which means I'm looking at parabolas, and I'm looking at the column on the left, because x is squared there. Now remember, our vertex is h comma k. So the first thing to find the vertex, I look at my formula. H is being subtracted from x, k is being subtracted from y, which tells me that's the opposite of what I see. So the vertex for this problem is -4, -1. Okay. Next, I need to find the focus. In the formula for the focus is h comma k plus p. Well, I don't know what p is yet. So, I need to find p. P is the focal length. Well, in my problem, in my formula, this amount equals 4p. So I have -6 equals 4p, which makes p equal -6 over 4, or -3/2. So when I go to do my focus, my -4 stays the same, but then I have -1 plus -3/2. So my focus is -4, comma, -1 and -1/2 is -5/2. So that is the point where my focus is. Next, I need to find the directrix. And the directrix is the formula y equals k minus p. Well, k was negative 1 minus negative 3/2 equals 1/2. So my directrix is y equals 1/2. Okay, so far we've answered vertex, focus, directrix. Now the last thing is focal width. And focal width equals the absolute value of 4p. So my focal width equals 6. And those are my answers. Okay. Questions on that example should be directed to the teacher, but we really went through our formula sheet, found P, used it to find all of our other answers. Okay, on the next example. So our next example is 5y squared equals 16x. Now in this case we have y squared, so we're using the column on the right for parabola. But notice that there's nothing with the y squared in our problem, so it means we need to divide by our 5. So we have y squared equals 16 over 5x. Now in this case, I don't have anything being added or subtracted, so my vertex is just 0, 0. Okay, our next order of business, we need to find P in order to find the focus in the directrix. So 16 over 5 equals 4p. P equals so P is 4 over 5. So now I know my P. I find that the focus in this case is H plus P comma K. So I'm going to have 4/5 comma 0 as my focus. My directrix is X equals H minus P, which means X equals negative 4/5, because 0 minus 4/5. And my focal width is the absolute value of 4p, so focal width is 16 over 5. And I've answered all my questions. Remember, you're going to do these all from your formula sheet. Now, sketching the graph. So to sketch the graph of a parabola by hand, I need a couple of bits of information. First, I need to know the vertex. I need the focus. I need the directrix, because I'm going to have to label all these parts. So the vertex is HK. Remember, it's the opposite, and this is a y squared. So because it's a y squared, I'm using the information on the right column of my sheet. So I need to determine, is this opening left or right? Well, because this is negative, start over. So, vertex, let's get that down first. My vertex is going to be -3, -2. Remember, our points are x, y, so I need to use the x part first, then the y part to get my vertex. Okay? Now, focus requires p. Well, 4p equals -16, which means p is -4. So that helps us with a couple of bits of information. First, because p is negative, it's going to open to the left. Okay? Next, I have my focus. The focus is h plus p. So -3 plus -4, comma, -2, which is -7, comma, -2. And then my directrix is x equals h minus p. So x equals -3 minus -4, which is 1. And now I have some things I can draw. First thing I would do, get my axis going. So we want to plot our points. First our vertex is at -3, 2. I'm sorry, -3, -2. So here's my vertex. My focus is at -7, -2. So here's my focus. And then my directrix is at x equals 1. And that's a line. So this is my directrix. Okay, so now we need to draw a graph. Well, I draw my graph. I know it's going to open and it's got to eat the focus. So it's going to look something like this. And it's just a sketch. I'm not asking for perfection, just a sketch. Okay, so we have our parabola. Remember, we need to make sure we label things. So let's try the next example. In this case, notice I have my square with the x. So I want to make sure I'm looking at the left column. I'm either going to open up or down. So my vertex. Remember, we started trying to identify our vertex and our focus and our directrix. My vertex in this case is 5, -2. Remember, for p equals 20. So p equals 5. And that is positive, which tells me it's going to open up. Focus is h, k plus p, so -2 plus 5 is 3. Directrix is going to subtract the 5. So 5, -7 is going to be my directrix. And now I'm at my graph. So label our points, vertex, 5, -2. 5, 3. And 5, -7. So, remember, this is our directrix, our vertex, and our focus. Make sure we're labeling everybody. Directrix, in this case, is a straight line going left and right. Got my vertex is going to eat my focus, curve around it, and there's a sketch of my graph. And this should make some sense to you based on the information we did on translations before. Normal x squared, I'm shifting 5 units to the right and 2 units down. So my vertex moved over and down, and there's my standard parabola. Now, last but not least, find an equation in standard form for the parabola. You're going to have to do some picture drawing in this case to help yourself out. Figure out where things are. So I need to write an equation. My vertex is 0, 0. My focus is 0, 2. So here's my vertex. Here's my focus, which means that my graph, if it's eating the focus, is going to be an up and down. Why is that important? Because it tells me I need an x squared. So my standard is x minus h squared equals 4p times y minus k. Well, what do I need to know? I need to know h, I need to know k, I need to know p. to write my equation. I know h is 0 and k is 0 because my vertex is h, k. What's p? Well, p is this distance between the focus and the vertex. And that's 2, because k plus p is 2, which makes p equal to 2. Now, plug them into your formula. So, x minus 0 squared equals 4 times 2 times y minus 0. Well, x minus 0 is just x squared. 4 times 2 is 8y. And that is my equation in standard form. Alright. Let's try the next one. Focus is negative 4, 0. Directrix is x equals 4. My focus is at negative 4, 0. My directrix is at x equals 4, which if that's my directrix, remember that's this line. And if over here's my focus, that means my graph is opening to the left. So that means I need a y. So y minus k squared is 4p times x minus h. That's how I tell which way my graph is going. Which function do I need? So remember, we need h, k, and p. The vertex is halfway between the focus and the directrix. Well, the distance here is 1, 2, 3, 4, 5, 6, 7, 8, which makes this my vertex. So h and k are once again 0. Now what's p? P is this distance here, which was 4. So y minus 0 squared equals 4 times 4. X minus 0. My final answer, y squared, equals 16x. And those are my equations in standard form. Let's go ahead and try the next two. Take a minute and see, go and pause the video and see if you can do these on your own, and then come back. Remember, for each one, you want to know what's h, what's k, what's p, and use your information to draw your graph. Now for this first one, graph not necessarily so helpful. I got my vertex, which is 0, 0. It's telling me it's opening to the left, which means p must be negative. So focal width is 12. So over here you can see 4p equals 12, means p must be 3. But I said p has to be negative, so p is negative 3. Now if it opens left, it's a y squared problem. So I have y minus k equals 4p times x minus h. So y minus 0 squared equals 4 times negative 3 times x minus 0. And I get y squared equals negative 12x. Bottom one, once again they're giving me the information. H is negative 3, k is positive 3, opens down. Down and left are negative, so p must be negative. Well, my width, 4p, equals 20, so I get p equals 5, had to be negative, so now I got a negative 5. Go back and plug them in. It's a down, so it's an x minus h squared equals 4p times y minus k. Plug things into their spots. X minus negative 3 equals 4 times negative 5 times y minus 3. And I'm going to get x plus 3 squared negative 20 times y minus 3. So that's what we should get for our second equation. Alright, let's try again. So, your exit ticket. Please ask teacher for the paper copy of your exit ticket at this point. And your homework. And all of this information can be found on eShop.